Hello class, for this video, we'll look at section 4.2 of your chapter 3's notes on graphing techniques. Alright, it's actually under the big category of section 4 on conics, which includes graph types like ellipse, circles, parabola, and also I think later on hyperbolas. Alright, so we are particularly now looking at the section on 4.2 parabolas. Actually, parabolas types of graphs are not foreign to you. Last time when you learned quadratic equation, the quadratic equation curve actually is a parabola, the U-shaped graph. Because if you look at the standard form for this second type, all right, the left-hand side surely can be expanded or to x squared quadratic equation, quadratic expression in x, all right? And then let's say if I divide the b over 1 over b, then as you can see, it's just simply a graph type of y equals to 1 over bx squared plus, let's say, cx plus d, all right? So actually it's a U-shaped graph if 1 over b is positive, all right? If 1 over b is negative, then it's a inverted U-shape, all right? So if we were to reverse the x and y, all right, so now the square goes to the y. So actually for this second one, it will be the type of equation that has x equals to a quadratic expression in y, all right. Hence it will be the reverse, either a nice C-shaped graph or the inverted C-shape, all right, depending on the sign of A. If A is positive, is this type. Okay, then why the trouble of writing things in this standard form? Okay, because in the standard form, okay, when you have a complete the square for y and x for the second case, then this value hk, right, will give us the vertex very nicely, meaning all these vertex here, okay, will be having coordinates hk, okay, hk here as well, because h is the one that goes with x, even for this second case, is hk. Okay, let's look at an example, all right, to illustrate this. Let's say if I look at this quadratic equation, okay, x minus 1 squared plus 3, all right, then you know that it's a U-shaped curve, isn't it? Okay, in this form, standard form, x minus 1 squared equals to y minus 3, then we know that 1, 3 will be the vertex. Is that right? But I think with your knowledge from your secondary school time, you also know that 1, 3 is actually the vertex, right, of this parabola, this U-shaped graph. Okay, actually, in fact, the whole graph will look like this, all right? 1, 3. Okay, it cuts at 4 here, all right? So let's look at the related case. If I now switch the x and y, okay, actually I will get the standard form y minus 1 squared equals to x minus 3. The vertex becomes 3, 1 instead. Actually, in fact, because I've changed xy to become yx, right? So actually they are related. Or previously, xy as this go this way. Now think about it. X and y just swap around. So actually we will get a curve that looks like this. On the other way around, the vertex now is 3, 1. Okay, this is 3, 1, and it cuts at 4 here. Can you see the link between the two curves? All right, it's basically like swapping the x and y axis around. Okay, the x value has becomes a y and y becomes an x. All right, so that's the usefulness of the standard form. All right, it will give you the vertex. Okay, so let's look at this summary part. Okay, for each case, all right, the shape as mentioned, right? For this one, because it's x equals to y squared, all right, it will either be a C shape or inverted C shape, depending on the value of this coefficient for y squared. If A is positive, okay, then it will be a C-shaped graph. Okay, A negative, the other way around. Okay, for this one, second case, y equals to x squared, we know it's either U-shape or inverted U-shape, depending on the coefficient of x squared, right? Which is 1 over b. Okay, so if b is positive, okay, we know it's a U-shape and b negative, the other way around. Okay. All right, vertex-wise, okay, it will both be hk because h is the one that's tied to x, k to y. Also, hk will be all these vertices, coordinates of all these four cases. Okay, I'll just write 2, all right, but they're all hk. Okay, line of symmetry, okay, will be this one. Okay, for the first type of parabola. Okay, so it will be y equals to k. Okay, and the line of symmetry for U-shaped graph or inverted U-shape actually will be x equals to h, isn't it? Okay, because the x coordinates is h here. Same thing for the other one. Okay, focal point not important. All right, I think you have taken note of that during your attending the lecture, but I won't go through that. Okay, it's not in the syllabus. Okay, so let's look at example 10. Okay, so example 10 basically just wants us to sketch all these parabolas. And some of them are given in standard form like A and B, or C is not. So if it's in the standard form, then we know the where the vertex is, and we can roughly already gauge how the shape goes, how the curve goes, and just find the necessary, let's say, axial intercept if it exists. So let's analyze this. The vertex for the first one, since the first equation is in standard form, it will be 1 and -3, isn't it? Or because this part can be written as y minus -3. All right, so 1, -3 is the vertex, and because this coefficient is negative, or it's a y equals to x squared graph, we know it's an inverted U shape with vertex at 1, -3. Okay, next, for part B, is x equals to y squared graph, or is C-shape or inverted C-shape. But because this is positive, so it's a C-shaped graph, and the vertex is at 3, -2. All right, so let me draw a rough sketch first. It's a C-shaped graph, vertex at 3, -2. Okay, last case, because it's not in standard form, let me very quickly complete the square to get the standard form. Alright, so upon completing the square, okay, this will be, sorry, this should be minus. Okay, so the standard form goes this way. Alright, so it's a x equals to y square graph, C or inverted C shape, but because this value is negative, so it's an inverted C shape and vertex at 1, 1. Alright, so let me do a quick sketch. Inverted C shape, vertex at 1, 1. Okay, knowing this is quite important, then I don't need to go through the trouble. Actually, if you look at the outline of the working for before sketching, okay, we find out the axial intercept and so on. But actually, if you know roughly how the graph goes, you can actually omit some of that. For example, if I know the vertex of the first case is at 1, -3, or it should go something like that, isn't it? Okay, 1, -3, so the axis should be somewhere here. And actually, there's only a need to find the y-intercept. That means when x is 0. So this case, actually, you want to omit out. Certainly, okay, because there won't be any x-intercept. Okay, so yeah, just highlighting some usefulness of it. The second case, knowing that the vertex is at 3, -2, okay, the axis will go in this manner, something to this extent. So there's only going to be a x-intercept. All right, and the last case, okay, something to this effect. I don't know whether it passed through nicely 0, 0. Actually, yes, I think it will be the case. Yeah, because when x and y is 0, 0, 1 is equal to 1. Yeah, very nice. So this will be the curve, you see. So there's only a need to find what this other y-intercept is. All right. So with this and going through all these details of this first one, y-intercept is at negative 3.5, then we get the full graph already. All right. So I'll very quickly show you the solution. Okay. All these you might have already taken down during the lecture. Okay. So basically, if the question is about sketching the graph, yeah, you just do the necessary working, right? We'll be marking more based on whether all these important features are reflected correct in the sketch. So should you reflect them? Yeah. So even without working. Can? All right. Case B, all right, will be this curve. But let me show the nice version. This will be the answer. Please label your axis. Okay, and origin also. 4, 0 here, 3, negative 2 here. Why 4, 0? Because when y is 0, x is 4. All right. Okay. The other details. Okay, you can take notes. All right. There's no, if you know there's no y-intercept, we don't even need to proceed to find it. All right. Okay, and the last case. Okay. I've completed the square nicely. All right. Okay. So knowing that you'll be this type of graph that we're dealing with. So as mentioned, let's just need to find this one when x is 0, isn't it? Okay, it's either 2 or 0, the y value. Okay, there's no need for, actually, yeah, this will also give you x equals to 0, isn't it? Okay, when y is 0, x is also 0 because the graph passes through the origin. Okay, all right, so that's all for this section. All right, on 4.2. Thank you.